Hello ladies, gents, and everyones. It is Thursday, May 12th, and we're here to talk about this week's space and astronomy news. But first, some housekeeping. Okay, so two things. First, I'm going on vacation in less than 24 hours. I'm going to be gone for 2 weeks, and unfortunately I didn't have time to pre-make any videos to release while I'm gone, so you are just not going to see me for 2 weeks. Sorry about that, but I'm really excited, and I will be back for the news, of course, on the 26th of May. And the second thing is, if you look down here or maybe up there, somewhere on your screen, you should see my subscribers numbers, and you might notice that it is either at or very close to 1,000. And since we use base 10 here on Earth, that's a really exciting number. So I wanted to celebrate, and I ran a little poll, and a lot of you wanted to do a live. So I'm planning to do a live on Friday, May 27th at 5 p.m. Central. It's just going to be kind of casual, probably going to do a couple space-themed drinks, talk about some space news that we can chat about, answer any questions you guys have, and I'm going to do a couple merch giveaways during the live. So please do consider checking that out, and if you're not already one of those 1,000 galactites, come on in, the water's fine. Okay, back to the news. Okay, so last week our favorite extraterrestrial helicopter gave us a little bit of a scare when it unexpectedly dropped communications with the Perseverance rover. Of course, Ingenuity is already operating well beyond its planned lifetime and mission, but that doesn't mean we're ready to say goodbye, and luckily it seems like we won't have to, at least not quite yet. Side note, we may not be so lucky with the InSight lander. NASA has announced that they're going to make an announcement. Pre-announced? I don't know. Lots of announcing there. Anyway, that they're going to make an announcement about the InSight lander next week, and it's probably not going to be good news. But Ingenuity has reestablished comms with Percy. The comms drop appears to be due to a timing mismatch that was caused by a low power state on the helicopter, possibly due to the increase in dust in the atmosphere, which is decreasing the amount of solar power available. As the amount of dust continues to increase in the upcoming Martian winter, it will be increasingly difficult for the helicopter to keep its batteries charged. The team has implemented a new power plan, which they hope will help with that, but TBD how that will go. When we think of the Hubble Space Telescope, we tend to think of these amazing deep space observations like the Hubble Deep Fields, the Pillars of Creation, and yes, the telescope can take images closer to home, like its iconic images of the giant planets, but almost certainly most of us do not think of it as an asteroid detection observatory. Yep. A team of astronomers alongside citizen scientists at Zooniverse have been using archival Hubble data to identify asteroids. These asteroids show up as streaks on Hubble images that were taken of other scientific targets. The study, published this week, identified 1,701 asteroid trails, including possibly over 1,000 previously undetected asteroids. These asteroids could be smaller and fainter than the asteroids that are typically discovered by ground-based observatories, and studying the asteroids and their orbits can help us learn about the formation and evolution of the solar system. Is it just me, or does it seem like it has been forever since Boeing's OFT-2 mission was scrubbed? It was actually just in August, so less than a year ago, but anyway, if you've been a galactite for a while, you know that it was stuck valves in the propulsion system that led to the latest roadblock for that launch. Well, Boeing seems to have figured it out, hopefully now accounting for summer humidity in Florida, and the OFT-2 mission is now scheduled to launch on May 19th. Yesterday, NASA and Boeing held a flight readiness review for the mission, and everything was good to go, so we are looking forward to that launch at 6:54 p.m. Eastern next Thursday. As a reminder, OFT-2 is an uncrewed test mission that should deliver cargo to the International Space Station to demonstrate the capabilities of the Starliner spacecraft. The sun is the star nearest and dearest to us here on Earth, and its proximity means we can do things like measure all the little tiny bits of elements besides hydrogen and helium in it. Astronomers call these metals. This gets harder to do for stars that are farther away, but astronomers just set a new record for a star besides the sun that has the widest known range of elements. This star is called HD 2222925. I might have messed up the number of twos there, but anyway, it's a evolved red horizontal branch giant star that's located about 900 light years away, and astronomers have now identified 65 elements in it, including 42 heavy elements. These heavy elements are particularly interesting because they're formed by something called the R process, which only happens in a couple possible places in the universe. Now, astronomers got a big assist on R process elements back in 2017 with the observation of a kilonova event, which proved that a lot of these elements are formed during neutron star mergers. But that was just one event. Some of these elements can possibly also form in supernovae events, and stars like HD 222925 can help us understand the formation process of these heavy elements, so very exciting. Y'all, this last one is hot off the presses. I mean, literally an hour and a half ago this was released. So the Event Horizon Telescope collaboration announced today that they have successfully imaged the black hole at the center of the Milky Way. Called Sagittarius A star, this source was first discovered back in 1933, and over the years, observations have shown that it must have a high enough mass and a small enough size to be a black hole. In fact, Ghez and Genzel both earned a Nobel Prize in Physics in 2020 for this. And now we actually have direct visuals of it, of the gas that is orbiting the supermassive black hole and the black hole's shadow, which is the dark region at the center. This is only the second time we've ever directly imaged the shadow of a black hole, and it's so exciting to do it for our very own galaxy. And it took a lot longer to do Sag A star rather than M87, which was the previous one, because even though Sag A star is a lot closer to home, it's also a lot smaller. It's a measly 4 million solar masses compared to over 6 billion for M87. This made Sag A star a lot more challenging of a target, but they have finally done it. This effort used 8 telescopes located throughout the globe, and the work involved over 300 scientists from 80 different institutions. So a really huge effort, and just congratulations to everybody involved. From a scientific perspective, the similarities between Sag A star and M87, especially on the smaller scales, show that general relativity, as expected, is what's actually really governing what's happening there. And then the differences in the material that are accreting onto these black holes can help us learn about the formation and evolution of supermassive black holes and their host galaxies, which is work that scientists are doing right now using this very exciting new data to test their theories and models. Again, congratulations to everyone involved, and just really, really cool to see this, and such a good note to end on because it is going to be 2 weeks until I see you again. But in the meantime, I hope you have a good one. Thank you so much for watching, and don't forget to join me on Friday, May 27th at 5 p.m. Central for live. Okay, bye!